Hello, this is Mrs. Taylor, and I'm going to walk you through how to evaluate a limit of a rational algebraically. So what we've looked at already is limits that when I use direct substitution, I get a value. But what about those rational functions that if you were to find the limit when you use direct substitution, you get an undefined value, for example, 0 on the bottom. And so you have two options that you can try in that case. They are to divide out common factors or to rationalize. So depending on what your rational function is, these are two ways that you can simplify the expression in order to find out what the limit is. So first let's look at dividing out common factors. If I have this limit here, find the limit as x approaches -3 of x squared plus x minus 6 all over x plus 3. And if I use direct substitution by plugging in -3 into the denominator, I get 0. More than that, if I plug -3 into the numerator, I get 9 minus 3 minus 6, which is 0. And that's called an indeterminate form, 0 over 0. Another indeterminate form is infinity over infinity. And so that's very undefined, which means I've got to find some way to simplify this expression in order to make direct substitution work. And so if you notice, if you factor the top, you get a common factor between the numerator and the denominator. So in factored form, it would look like this. The limit as x approaches -3 of x minus 2 times x plus 3 all over x plus 3. And so what I notice is that the x plus 3 from the top and the bottom would cancel. And then if I use direct substitution now, I get an actual value. Equals -3 minus 2 is -5. And if I look at the graph, that limit is confirmed because if you look, there's a hole there at x equals -3, but to the left and to the right, it is approaching -5. And so dividing out a common factor is a great strategy to use in order to evaluate a limit algebraically. The other method is rationalizing. So if I get an indeterminate or just an undefined answer, I can also try to rationalize to see if I can get an expression that gives me a defined answer with direct substitution. So in this case, we have find the limit as x approaches 0 of the square root of x plus 1 all minus 1 divided by x. And rationalizing means I multiply by the conjugate. So I'd multiply top and bottom here by the square root of x plus 1 plus 1. That would be the conjugate of the numerator. And after I simplify things out, hopefully I will get a rational that with direct substitution will give me a value. And so multiplying by the conjugate would look like this. And then I would multiply the numerators and the denominators. So of course when I multiply a square root by a square root and it's the exact same thing inside of the radical, those square roots cancel. So the numerator would, after multiplying that out and my other terms, my numerator would look like this, because the middle terms would cancel, and then I would have my 1 from where these square roots cancel with the -1 from when I multiplied -1 times 1. And if me just talking about it confuses you, go back and multiply it out yourself. It'll make a lot more sense. And then the denominator, when I multiply it out, I can just write it out as x times this entire denominator. And so when I write it out, it would look like this. X times the square root of x plus 1 plus 1. And the reason why we don't need to multiply that out is because if I use direct substitution, not when you use direct substitution, but the reason we don't multiply it out is because if you look at your resulting rational, you have an x on the top and the bottom. This x is being multiplied by this entire expression. Therefore, I can cancel those x's. And now when I use direct substitution, I won't have a 0 on the bottom, because when the x's cancel, that leaves me with 1 on the top. And so when I use direct substitution, I would have 1 over 0 plus 1 is 1, the square root of 1 is 1, and then 1 plus 1 is 2. So my limit would equal 1/2. And so if you're faced with a limit of a rational, and when you use direct substitution you get an indeterminate or an undefined answer, try to either cancel out common factors or rationalize if you have a radical, because you may get a simplified expression that works with direct substitution.